Today, we will take a look as to how can we find equations for sine and cosine given the graph. So the main idea here is the following, is that we can use the amplitude and we can also use the frequency to come up with equations for sine and cosine. Now, one thing to remember is the following. Frequency, we have defined this as the amount of times that pattern, which we know that this is just another word for cycle when it comes to trig functions, the amount of times that the cycle repeats in an interval of 2 pi. So please remember that we will use the amplitude and the frequency to properly come up with equations for sine and cosine. And remember that frequency is just how many times does the pattern repeat in the interval of 2 pi. All right, let's get started here. Let's look at some equations here. So the direction is here. Let's find the equation for the following graphs. And anytime you want to find out an equation for a graph, when it comes to sine or cosine, the first thing that you want to do is figure out what is the amplitude and what is the frequency. So remember that amplitude is how far up or how far down are you going on the graph. So it is clear that the center or the midline of the graph, it's centered at 0. Notice that your graph, it goes all the way to 3, and then it goes all the way down to -3, and then it should go all the way to 3, because remember, this is a pattern. So here, just like we have discussed before, the amplitude in this case is 3. Now, let's take a look into the frequency here. The frequency is how many times does the pattern repeat in the interval of 2 pi. So let's see, this is the interval 2 pi. From 0 all the way, so we're going to be taking a look from 0 all the way to 2 pi. So notice that at 0 you start at 0. So if we follow this pattern, it goes up and then 1 down. This is not a full cycle here because we still haven't covered those values that are on the negative y. So we're going to continue here. Or imagine that goes to the line. So notice that in the interval from 0 to 2 pi, you repeat the cycle just once. So this is an indicator that the frequency here is just 1. Because from 0 to 2 pi, we only perform one full cycle here. So now that we know that this is an amplitude, it has a value of 3, and the frequency has a value of 1, what we have to determine is this an interpretation of a sine or a cosine function? And remember that if your graph starts at 0, so if your graph starts at 0, then this is an indicator of a sine function. Let me move this here. Okay, perfect. So we have an amplitude, we have a frequency, and because your graph starts at 0, we know that's a time function. Once you know this 3 pieces of information, then you can write down the equation for this graph. Because the equation of the graph, it's always going to have, at least when it comes to sine, is going to be y equals the frequency times the sine, parentheses, the amplitude. Nope, I got those backwards here. Is the amplitude. This is the amplitude times the sine, parentheses, and now the frequency. And then we're just going to say it comes to the value of theta because we're looking for sync. So we have those values. We know that the amplitude is 3. So it's going to be 3 sine. We know that the frequency has a value of 1. So that's 1 theta. So, I mean, if you just want to simplify this, you got 3 sine 1 times theta is just theta. So this will be an equation such that if you graph this equation, you will obtain this graph. Okay, so now maybe the first example is not that straightforward, but one thing to keep in mind is that all you need to know is just three facts. What's the amplitude? What's the frequency? And are we talking about sine or cosine? Once we know those three values, then we can come up with the equation. So let's do one more example here. So here we have it. So here's your, notice that it looks like it's the same function as before, but there's slight differences here. But still, what we want to find out is what's the amplitude and what's the frequency first. So let's start here. Let's start with the simple one. So let's figure it out. What is the amplitude? So how high or how low your graph goes. So let's look at our graphs here. So here's our graph. So if we notice here, it goes all the way to 4, and then it goes all the way to -4. I guess I forgot to write down here that this is -4. So it goes all the way to 4, then it goes all the way to -4, then all the way to 4, all the way to -4. So it's a little bit simple to see that the amplitude here has a value of 4. All right, so we got the amplitude, which is perfect. We got 1/3 down. So now let's see, can we figure out the frequency? Okay, well, this is going to be a little bit tricky here, because notice that it's not clear where pi/2 is in your graph, just like it was in example 1. In example 1, here says 2 pi. It's right here. But notice that all they're giving us is that it's pi/4. So what we can say here is that every single square has a pi/4. So let me just move this here on the side. So if this is pi/4, the next square, we're going to add another pi/4. Where, let's just do it here on the side, pi/4. It's supposed to be a 4 here. So pi/4 plus pi/4. They have the same denominator, so you can add the numerator. So this is 2 pi/4, which 2 divided by 4, this can be simplified as pi/2. So we know that the next square, or the next line, is pi/2. If you add that up, you're going to get the 3 pi/4 here. And you will see that in here, this is a pi. Okay, perfect. So let's see what we have here. Well, let's look at how long does it take for us to complete one full cycle. So let's say we start at the top. We start at the top, and it's going to take all this time to complete that full cycle. So notice it goes up and it goes all the way down, and then once it hits up, just like it was explained on the previous video here, this is a cycle. So now, how many cycles are we going to complete in the interval of pi/4? I'm sorry, in the interval 2 pi. Well, we know that one cycle, we do one cycle in pi/4. So how many cycles in 2 pi? There's a question, because to figure out the frequency, we need to see how many cycles there is in 2 pi. Well, we know that every half pi, you complete the cycle. So how many halves do you need to complete in order to get a whole 2 pi's? Well, notice that here, we're going to complete the cycle 4 times. We can just do some simple math. So pi/2 plus pi/2, this is going to be 2 pi/2, which is just a pi. But notice that we don't want just all the way to pi, we want 2 pi. So we need 4 full cycles in order to complete a 2 pi. So we can do the simple math here. plus another pi over 2. So that every one of them has the same denominator. So it goes 1, 2, 3, 4. So this becomes 4 pi over 2. And this becomes just 2 pi, which is exactly what we wanted here. So notice that we need 4 full cycles in order to complete 2 pi. So that means that the frequency here is 4 as well. So we know the amplitude, we know the frequency. So what we have to do now here is, are we talking about a sine or cosine function? Well, notice, did your graph started at 0? No, it actually started at the amplitude. Because the graph starts at the amplitude, then this is a cosine function. All right, so I mean, if we want to write down a function for cosine, it looks exactly the same as the sine function. The only thing that's going to change, instead of sine, it's a cosine. So this becomes y equals the frequency. I'm sorry, I always get those confused. Is the amplitude times the cosine, parentheses, now the frequency goes inside, times theta. Perfect. So, but we know those values. So y equals, what's the amplitude? We know that the amplitude is 4. Cosine, what's the frequency? We know that the frequency is 4 pi. So this will be your answer right here. Y equals 4 cosine of 4 theta. Now, this completes the lesson for today. So here is your entrance ticket. Find the equation for the following graph.